Welcome to AI Paper Podcast, where we break down the latest research for you. Today, we're looking at a paper that honestly tackles a massive headache for anyone in research or tech presenting their work.
Oh yeah, making those conference videos, it takes ages.
Seriously, hours and hours, right? For maybe a 5-10 minute video, you've got slides, your script, subtitles, the talking head video, and academic papers are dense, figures, tables, long context. It's a lot to juggle.
Exactly, and that's the problem this paper. Paper2Video, automatic video generation from scientific papers, goes right after. They offer two main things here. First up is the Paper2Video Benchmark. Okay, a benchmark, so data.
Yeah, 101 research papers paired with the actual videos the authors made. Plus, and this is key, they developed new ways to measure how good these videos are for, like, scholarly communication.
Not just if it looks good, but does it work?
Precisely. They have Present Quiz that checks if you actually learn the paper's content from the video. And IP Memory, which is about remembering the author and the work itself. Super relevant for conferences. Gotcha. And the second thing, that's the solution. PaperTalker. It's a multi-agent system, basically. Different AI bits working together to automatically create these videos straight from the paper text, an automated video generator for research papers.
You got it. And they use multiple agents for things like making the slides, doing the voiceover, adding subtitles, even generating the talking head. Critically, they figured out how to do a lot of this in parallel, slide by slide.
Okay, parallel processing, so it's faster.
Way faster, like over 6 times faster than doing it sequentially. But here's the really interesting part. Their experiments showed PaperTalker's videos didn't just match human ones, they actually outperformed them by 10% on that present quiz score.
Wait, 10% better. The AI video taught people the paper better than the human author's video.
That's what the results say. More effective knowledge transfer.
Okay, wow. We definitely need to unpack how they pulled that off. Let's dive into the architecture behind PaperTalker.
Sounds good.
So this PaperTalker system, you said it's a multi-agent framework. What's the thinking there? Why split it up?
Well, the idea is basically divide and conquer. Making a video like this involves very different tasks, right? You've got visual slide design, speech synthesis, timing, visual grounding with the cursor.
Right. Very different skill sets, even for AI.
Exactly. So they decoupled these roles into separate builders. There's a slide builder, a subtitle builder, a cursor builder, and a talker builder. It makes the whole system more manageable, scalable, and, flexible if you want to swap out components later.
Like an assembly line for making research videos?
That's a great way to put it. And the first stop on that line is the slide builder. Its job is to take the full paper text and generate formal academic slides completely from scratch.
Okay. And how does it do that? Does it use, like, PowerPoint templates or something? Actually, no. They made a pretty specific choice here. LaTeX Beamer. LaTeX. Wow. Okay.
Yeah.
That's formal. Definitely. Good for equations and stuff.
Yeah.
But isn't it way more complex than, say, XML or a PowerPoint file? Seems like it might slow things down.
It does add complexity, yeah. But they argue it's necessary for academic content. The precise typesetting, handling math, complex figures, things PowerPoint often struggles with automatically. LaTeX gives them that formality and, crucially, automated typesetting.
Okay. But how do they manage the complexity, the coding aspect?
Through something they call the coder-compiler loop. So one agent, the coder, writes the LaTeX Beamer code based on the paper. Then it tries to compile it.
And if it fails, like a code error?
Exactly. The compiler spits out errors or warnings. Those diagnostics get fed back to the coder agents like, nope, that didn't work. Try again, fix this specific thing. This loop forces the coder to keep refining the LaTeX until it compiles cleanly and covers the necessary content. The compiler acts like a correctness checker.
Clever. Using the compiler itself as feedback.
Yeah.
But even perfect LaTeX code doesn't guarantee good visual layout, right? You still get those annoying overfull H-box warnings or figures that are just slightly too big and run off the slide.
Totally. And that's a real weakness of large language models. They're great with language, with semantics, but they're not very sensitive to small numerical tweaks needed for visual layout. You can't just tell it make the figure 5% smaller reliably.
So how do they fix layout problems like an image being too big? This is where they introduce a really novel idea, tree search visual choice. Tree search visual choice. Okay, what does that involve?
Instead of trying to get the LLM coder to fix the layout directly, the system generates multiple versions of a slide with slight layout variations. For instance, it might try rendering the same figure at different scaling factors, like 1.25 times size, 0.75, 0.5, 0.25, whatever.
Okay, so it generates options.
Then, a visual language model, a VLM, which can actually see and understand images, acts as a judge. It looks at the rendered PDF outputs of all these variations.
So the VLM picks the best looking one.
Essentially, yes. It scores them based on things like, is the text readable? Is anything cut off? Does it look cramped? And it selects the variant with the best visual score. It's a smart way to use the strengths of both types of models, the LLM for content and structure, the VLM for visual assessment.
That makes a lot of sense. Okay, so the slides look good. They're technically correct, but a presentation needs a presenter, right? That brings us to the Talker Builder. What's its role?
Its role is all about adding that human element back in. You need a voice and ideally a face to connect with the audience and, maintain the author's identity.
Right, personal touch.
So it has two main parts. First, subtitled speech. They use models like F5TTS. You give it a short audio sample of the actual author's voice.
Just a sample?
Yeah, just a few seconds, apparently. And it can then generate the entire presentation script in a voice that sounds like the author.
Voice cloning, basically. Yeah. And the face.
For the talking head video, they use other advanced models. The paper mentions Hello To, or fantasy talking. You feed it a portrait photo of the author, and it generates a video of that person speaking the synthesized audio.
Okay, generating high-quality, deep-fake-style talking heads. That sounds computationally expensive. And slow. Didn't we say speed was a big goal here?
It is expensive, but they have a really clever trick to speed it up dramatically. It comes from understanding the structure of the final video product.
How so?
Think about a typical slide presentation. When you change slides, it's usually a hard cut, right? The background changes instantly, the content changes instantly.
Yeah, there's no smooth transition needed for the speaker across that cut.
Exactly. There's no need for the talking head video to be temporally continuous from the end of slide 1 to the beginning of slide 2. They realized they could exploit this.
So they don't need to render one long, continuous talking head video.
Precisely. They implemented parallel generation across slides. They generate the talking head video segment for slide 1, slide 2, slide 3, all at the same time, independently. Then they just stitch them together with the slide changes.
Okay, that's smart engineering. It sidesteps the bottleneck by parallelizing. That's where the 6x speedup comes from.
That's the main driver, yes. It makes the whole personalized video generation actually practical time-wise.
Got it. Slides, check. Personalized talker, check. What about the cursor? You mentioned a cursor builder. This seems crucial for guiding attention, especially with dense slides.
It's absolutely crucial and probably a big reason for that 10% win in the quiz metric. But making a cursor move naturally and meaningfully is surprisingly tricky. It needs to be synchronized with both what is being said and where that information is on the slide. Spatial temporal grounding.
Okay, space and time. How do they solve the space part? Knowing where to point.
So first, the system figures out the visual focus for each sentence in the script. Like, okay, this sentence is talking about equation 3, or this part discusses the blue line in figure 2. A VLM helps generate these textual focus descriptions.
Right, like little instructions.
Then they use another specialized model, something like UITARS, which is trained for computer interaction tasks, to translate that textual instruction, focus on equation 3, into actual screen coordinates. The XY pixel location on the slide.
Okay, so it knows where to put the cursor for each sentence. Now, the time part. When does it move and how long does it stay there?
That's temporal alignment. For this, they use a speech recognition model called WhisperX, which is good at getting very precise timestamps for each word in the generated audio.
Word level timing, okay.
By matching these word timestamps to the subtitles, which correspond to sentences, the system knows the exact start time, TS, and end time, T, for when each sentence is spoken. So the cursor jumps to the target XY location at time T, stays perfectly still while the sentence is narrated, and remains there until time T.
And then move to the next spot for the next sentence. Wow. That synchronization sounds key for making it easy to follow.
It really directs the viewer's gaze, effectively. No more hunting around the slide trying to figure out what the speaker is referring to.
Okay, the complexity of just the generation side is pretty incredible.
Yeah.
But like you said, the proof is in the results. Let's switch gears to the Paper2Video Benchmark and how they actually evaluated all this.
Right, because just saying it works isn't enough in research. You need data and metrics. The dataset they built is pretty substantial. 101 papers from top conferences over 3 years, ML, CV, NLP.
And these aren't simple papers, right?
No way.
Yeah.
They specifically chose long, complex ones. Average paper was, over 13,000 words, almost 45 figures, nearly 30 pages long. And the human presentation videos averaged around 16 slides in over 6 minutes. So a real challenge for any automated system.
Okay, challenging data. Now the metrics, this seems like a really important contribution too. Tailoring evaluation for academic video. You mentioned 2 dimensions.
Yeah, they thought about the dual purpose of these videos. One is conveying knowledge effectively to the audience. The other is author visibility and impact. You want people to remember your work and who did it.
Makes sense. So how do they measure knowledge conveyance?
That's the present quiz metric we talked about. They use a video LM, an AI that can watch and understand video as a proxy for the audience.
So the AI watches the presentation.
Watches the video, then takes a multiple choice quiz about the paper's content. The score reflects how well the information was transferred. It's a direct measure of teaching effectiveness.
Clever. Okay, what about the author visibility side?
That's where IP memory comes in. It's designed to measure how well the audience, again, usually the video LM, can recall specifics about the work and the author after watching. This ties into that real-world conference goal of making connections and having your work recognized.
Okay, present quiz for knowledge, IP memory for impact. Any other metrics?
2 more, focused on quality and similarity. Meta-similarity compares the generated pieces, the slides, the speech script, the subtitles, to the human-created versions. How similar are they visually? How close is the synthesized voices sound to the real author? They use VLM scores and audio embeddings for this.
So how faithful is it to a human-made equivalent?
Exactly. And finally, there's Present Arena. This uses the video LM again, but this time as a judge comparing pairs of videos.
It's a taste test.
Kind of, yeah. It does pairwise comparisons, generated video versus human video, generated versus another generated, asking the VLM which one is better overall in terms of clarity, engagement, delivery quality. It gives a score for perceived quality.
Wow, that's a comprehensive set of metrics. Before we hit the main results, you mentioned an ablation study about the cursor. That sounds important given how much effort went into it.
Yeah, they did specific tests isolating the impact of the cursor, and the results were, dramatic.
How dramatic?
They set up a task where the video LM had to locate specific information on the slide after it was mentioned. Sort of a where is X question. Without the cursor guiding its attention, accuracy was terrible. Like 0.084, basically. Couldn't find it.
Okay, almost 0. And with the cursor?
With the cursor builder active, providing those synchronized visual cues, accuracy jumped to 0.633.
Whoa, from 8% to 63%. That's a massive difference.
Huge. It absolutely confirms that the cursor isn't just window dressing. It's critically important for grounding the spoken information visually and making the content accessible. That spatial cue makes a world of difference for comprehension.
Okay, that really underscores the importance of that component.
Yeah.
So let's bring it all together. How did PaperTalker actually perform against other systems and the human videos?
It performed extremely well. Across the board, it generally beat other automated baselines like VO3 and Present Agent. It scored highest on meta-similarity, meaning its generated assets were closest to the human ones.
So high fidelity.
Right. And it also won in Present Arena, meaning the video LM judged it as having the best overall perceived quality compared to other AI systems.
What about human evaluation? Did real people agree?
Yes, human evaluation backed this up. PaperTalker was ranked 2nd overall, essentially comparable to the original human-made videos, and significantly better than all the other AI methods they tested.
Comparable to human-made is already impressive. But the real headline, the one that made us want to cover this paper, is that present quiz result.
Yeah, this is the stunner. PaperTalker didn't just match human videos on knowledge transfer, it beat them by 10 percentage points on the present quiz accuracy.
10% better at teaching the content. And you mentioned something else crucial.
Yeah, it achieved this higher effectiveness while being significantly shorter. The average PaperTalker video was only about 234 seconds, whereas the human videos averaged 375 seconds.
So faster to watch and you learn more. How is that possible?
Well, the thinking is the conciseness might actually help. Less time means potentially less cognitive load, maybe better focus. Plus, the effectiveness of the talker and cursor components seems undeniable.
Right, the ablations showed that.
Exactly. When they tested versions of PaperTalker without the personalized talking head or without the synchronized cursor, the present quiz scores dropped noticeably. Those elements, the engaging presenter, the precise visual guidance, are clearly vital for making the communication effective, not just efficient.
So it's the whole package working together, the formal slides, the personalized delivery, and that super precise cursor grounding.
It seems so. This really feels like a significant step towards practical, automated tools for researchers. PaperTalker shows it's possible to handle the complexity of academic papers and generate high-quality, effective videos automatically and much faster than humans can.
Okay, let's wrap this up. What's the big takeaway here for researchers, for presenters, for anyone creating technical content?
I think the main breakthrough is demonstrating that an automated system, PaperTalker, can successfully tackle these really challenging, multimodal, long context documents, scientific papers, and produce presentation videos that are not just good, but potentially more effective at conveying information than typical human efforts, and much more efficiently.
So here's the final thought to leave you with. If this AI framework, PaperTalker, can create a presentation that's objectively 10% better at teaching the material in a quiz and does it in significantly less time. Does this mean the optimal path for scholarly impact and visibility might actually involve automating this process? Are we hitting human limits in presentation design, especially when done quickly?
It's a provocative question. What exactly did the AI optimize? Was it just the conciseness combined with that perfect cursor timing? Did it exploit some aspect of attention or information processing that human intuition often misses under pressure?
Something fundamental about communication, maybe. We definitely encourage you, if you're interested, to check out the paper and their open source data and code. See what you think. That's all for this AI Paper podcast.